All right, welcome to Unit 5, Lesson 7. We are starting with more or less. We're going to go with the ready right now, and we're going to substitute the given value of x into the equation to find the value of y. Now, for number 1, we have 5x minus 9y equals 73, and we are substituting the value x equals 2. So we are going to do that in green. And to get started, we're going to rewrite our equation for number 1 with x replaced by the number 2, or the value 2. So to do that, we're going to write 5, and then in parentheses, we're going to put our 2. Right? That means to multiply. Minus 9y equals 73. Now that we have that, we need to get y alone, and in order to figure out what y is, we need to get y alone. So we're going to simplify a little bit. We're going to make 5 times 2 equals 10 minus 9y. Oh, there we go. Minus 9y equals 73. We're going to subtract the 10 from both sides. So minus 10 on the left side, minus 10 on the right side. Oh, there we go. And now we should be left with minus 9y equals 63. All right, we're actually going to write this up and to the right a little bit higher just to give more space. So minus 9y equals 63. Our last step to get y by itself is to divide both sides by negative 9. Divide by negative 9 on both sides. And we get y by itself. Y equals 63 divided by negative 9. I know that 63 divided by 9 is 7, and there's one negative sign, right? One minus there, one negative, which means our solution should be negative, because a positive divided by a negative is negative. 63 divided by 9 is 7, so we should get y equals negative 7. Y equals negative 7, there we go. And we will circle that as it is our final answer. So that's the first question done. Now we're going to move on to question number 3. And our value that we can substitute right off the bat is x equals negative 5. So we're going to rewrite our equation and replace any x we see with negative 5. So 3x, or 3 times negative 5, right, minus 8y, equals 1. We're going to simplify a little bit. 3 times negative 5 is negative 15. So we have negative 15 minus 8y equals 1. We add that 15 to both sides, plus 15 and plus 15. Now we have no numbers left on the left side. We just have the minus 8y, or negative 8y. It did not really like what I did there. Minus 8y equals 1 plus 15 is just 16, is left on the right side. And our final step is to divide by negative 8 so that we get y alone. Divide by negative 8 on both sides. We end up with just y on the left side, and that is equal to 16 divided by negative 8 is just, there should be a negative, right? Because we have a positive divided by a negative. So it should be negative, and 16 divided by 8 is 2. So we end up with y equals negative 2. All right. Zoom out a little bit here and scroll down. Use the given value to find the value of the variable that's not provided. So it seems like this is just the same, but instead of using x's and y's, we're now using any two variables that they give us. So in this case, they gave us a and b, and they've provided a value for b, so we can plug that in. All right. So we will switch back to green here. So we have 5a plus 2b equals negative 37, and we're going to substitute b equals negative 1. So let's write down our problem with that substitution done. 5a plus 2 times b, where b is negative 1, is equal to negative 37. We're going to simplify, or we're going to do this multiplication out. 5a plus, oh, it's actually not going to be plus anymore, is it, right? Because we're adding negative 2. Well, we can do that. We can write it as plus negative 2. That's fine. 5a plus negative 2 equals negative 37. And now we want to get rid of that negative 2 on the left side. So we're going to add positive 2, right? We're just going to plus 2 on both sides. We get 5a. It hasn't copied down yet. There we go. 5a equals negative 37 plus 2 is negative 35. I wrote 37 again, though. That's a mistake. There we go. Is negative 35. And then our last step is to divide both sides by 5. So we end up with just the a on the left side equals negative 35 divided by 5 is negative 7. All right, so a equals negative 7. Which means that in this equation it gave us, if b is negative 1, then a is negative 7. All right, we're going to continue at the top of the next page, so let's scroll out, zoom out and scroll up. Here we go. Oh, we're not onto that one yet. There we go. So it has another equation for us. This one has m as a variable and z as a variable. With m as a variable, we will rewrite this equation because we know that z is equal to negative 9. So we are going to rewrite 2m plus 3z, except instead of writing z, we're going to write negative 9. So 3 times negative 9, in parentheses, equals negative 22. Negative 22. All right. And now our first step is to simplify. So we have 2m plus, right, plus 3 times negative 9 is negative 27. And that is equal to negative 22. Then we're going to add 27 to both sides, because if we add 27 to the left side, it'll go away. So add 27 to both sides. All we're left with is the m on the left side, right? 2m on the left side is equal to negative 22 plus 27 is going to be just positive 5. And now we divide both sides by 2. Divide by 2. We have m equals 5/2, or we can also write it as a decimal. M equals 2.5. Right? M is 5/2, or 2.5, or 2.5, however you want to say it. But m is equal to this value that is halfway between 2 and 3. All right, let's go look at what it wants for number 10. It's the set portion. All right. So we need to, we have to graph two things. All right, graph, right, this portion, which we'll do in purple, and this portion, which we will do in green, on the grid below. All right, let's do that. Before we get to any of the graphing, let's just make sure that we are, we're going to write on this grid, assuming that each of these boxes is worth 1. So 1, 2, 3, 4. So this is going to be 5. Just making sure we have our values down. Right. So that's going to be 5. 6, 7, 8, 9, 10. It looks like this is going to be 10. 1, 2, 3, 4. This is going to be negative 5. 1, 2, 3, 4, 5. This point here, or this value down here, is going to be negative 10. And then we have to go to the right and to the left. 1, 2, 3, 4, and 5. That's going to be the 5 marker. 1, 2, 3, 4, 5. This is going to be 10. And finally, 1, 2, 3, 4. That's going to be 5 to the left, which makes it negative 5. 1, 2, 3, 4, 5. This is going to be negative 10. All right, so we have our marks down on the axis just so we know like where we are situating all of our inequalities and such. So let's switch back to purple. All right, now we're graphing. So first, y is less than 3/4 x minus 2. All right, so the minus 2 tells me that this is going to intersect. Let's make the point a little bit bigger so that we have it very clearly. There we go. Yep, 3 should be big enough. All right, so it's going to intersect at minus 2. That's right there. And it'll have a slope of 3/4, which means if we go if we go up 3, we have to go over 4. So 1, 2, 3 up, and 1, 2, 3, 4 over should be right there. 1, 2, 3 up, and 1, 2, 3, 4 over should be here. And we can't do another one that way, but we could also go down 3 and over 4 to the left to plot some points down here. 1, 2, 3, 1, 2, 3, 4. All right, so those should be our points. And since we are graphing an inequality that does not have the equals, right, we should make a note here that it's not equal to, right? We are not writing an equal to there. And we'll also take note we're not writing equal to there, which means it's going to be dashed lines. So let's make a little bit of a dash here. Let's start with some dashes in between. Is it going to work? Right. It's not going to be as perfect because we can't write as perfectly. Like we can't do one of those straight lines that this tool lets us draw. We can't do that dashed, but that's okay. So that's our first line, and we are graphing y is less than that. So since y is less than that, we are only taking the y values, right? We're only taking points where y values fall underneath that line, right? Less than that line. So that is going to be the portion that is down here. So we're only looking at the stuff that is down here, right? So that's going to be our pink and purple. Oh, messed that up a little bit. So let's try to take some steps back. Oh, it seems like it's not working. All right, that's fine. It won't let us go backwards. That's okay. We will just leave that. Actually, we can probably just erase all of it. Aha! In one fell swoop. So we'll go back. We'll try again because I didn't like how that looked. So let's keep it on the page this time. Right? If we keep the pen tip down, it'll let us fill in all on the same layer. So there we go. So that's our first inequality. Now our second inequality. It's going to take a little bit more, right, about the same amount of work that we've already done for the purple, but we're going to do it now for green. We are now graphing y is greater than 3/4 x plus 3. So let's find plus 3. 1, 2, and 3 should be right there. And now our slope is 3/4, so we're going to go up 3 and over 4. Up 3 over 4. So right there. Up 3 over 4 should be there. Down 3 and to the left 4. 1, 2, 3, 4 is here. Down 3 to the left 4 is here. And that's all we can fit on the page. And now this is also going to be a dashed line. So we are, right, we're going to try to dash our way right through and see how it goes. All right, that wasn't so bad. The first dashes were a little bit rough, but that's okay. We'll make them a little bit better. All right, so there are our dashes, there's our arrow, and now the shaded region, let's see, y is greater than, so we're only going to shade in values that are, or points rather, that have above the line. right, that can be where their y values are above the line. So that's going to be the stuff that is above and to the left. All right. There we go. That portion. All right. So we have graphed both of them and done our shading. Perfect. Can you name, all right, so part B, can you name 3 points that satisfy both inequalities for the system? Well, satisfying both inequalities means a point that's in both the shaded regions, right? And there is not any overlap between the shaded regions. So I'm going to say no, I can't do that. Oh. No, I can't do that. There's no overlap, right? There is no overlap. Right, so there's no overlap between the two shaded regions, meaning, right, any solution to one inequality is not a solution to the other, right? There are no points that satisfy both, right? And it's because they actually have the same slope. Oh, so that's actually, I was just talking about it. That's actually part C. What's different about this system and most of the others you've seen so far in this unit? There's no overlap, right? There's no overlap. There is no overlap because the slopes are the same. No overlap. Oh. Because the inequalities have the same slope. They have the same slope, and their regions are separate, right? Are separated by a gap. Are, oh boy, are, nope, not paste again. I don't know what it's pasting. All right, are separated by a gap. By a gap. There we go. All right. Part D, here we go. How could you change the inequalities so that there would be points that satisfy the system? Well, there's two things we could do, right? We'd either change the direction, right? If we change one of the greater than, right, to a less than, or we change the less than to a greater than. So we could change the inequality sign. That would do it. Change the inequality. We'll call it a direction. Direction. Wow, that does not look like direction. I apologize. I'm going to rewrite this. Bear with me. Change the inequality direction. Or change the slope, right? Change the slope of one of them. Change either slope. There we go. Right, so if we do either of those things, right, if we either change the direction of one of the inequalities, right, if we change greater than to less than or less than to greater than, that'll have there be overlap, so that'll give solutions. Or if you change either slope, then at some point the two lines will intersect, which means at some point the regions will overlap. All right, and now we're on to number 11. Let's see what 11 has for a question. All right. Use the graph of the system of inequalities to determine which of the points listed would be solutions to the system. Select all that apply. All right, so it's given us 8 points to consider. I think we should just label, we should put all these points on the graph and see which ones are in the right place. So we're going to do, let's do all of the points in, how about we do all the points in blue? And then the ones that are in a good spot, we will circle with green, and the ones that are not, we'll circle with red. So that's what we'll do. All right, all these points are going to be in blue. All right, so we'll do all the points in blue first, and then we'll figure out. So A is at 4, 0. 4, 0 is right here. Nope, didn't mean to make a note. Didn't mean to do that either. What's going on here? There we go. So that is A. Oops, sorry. That's our point A. All right. Our point B is 2, -2. 2, -2. That's right there. That's B. All right. C is at 1, 2. 1, 2. That's our point C. D is at -2, -3. -2, -3 would be right here. Right, that's D. Our point E is at -4, 0. That's right here. This is E. Oh, didn't quite get it. E. F is at 5, -2. So we go over to the right 5 and down 2. So that is our point F. Oh, there we go. G is at 0, 2. So 0, 2 is here. Oh, it's right next to C. Interesting. Right, so G is right there. And finally, H is at -1, 6. -1, 6. So G is way up there. Or sorry, that's H rather. H is the one that's way at the top of the page. All right, so that's H way up there. All right. Now, we are trying to figure out which ones are in both, right? Use the graph of the system of inequalities to determine which of the points would be solutions to the system. So before we actually get to that, let's consider like what region, and we're going to highlight it in this blue, right? Because actually blue gets used. Let's highlight it in purple. No, let's highlight it in orange. I'm deciding on orange because orange will contrast nicely with the green and the blue. So we want only the points that are in the shaded region here, but that are not, right? They can't be on this line because this is not included, right? So this line does not include, right? And we only want the stuff that would be, right, in between these two lines. And they would go on forever, but we're only looking at the stuff in here. So from that, it looks like B and F are the good ones, right? B is good and F is good. And all the others do not meet the requirements. Now, we definitely know that like C and D and E and G and H, right? These ones don't work, right? There's no question, right? D does not satisfy the blue, right? E does not satisfy either one. G only satisfies the blue. C only satisfies the blue, right? The only questionable one is A. Now, why wouldn't A satisfy both solutions? Well, because A, the point 4, 0, right? That's right on a line, right? It's right on the green dashed line, but the dashed line means that it's not equal to, right? And since that would be equal to, right, that falls directly on the line, the dashed line means it's not included. So A is not included, right? So that is our last little elimination, right? A is eliminated. It's only B and F. Only B and F. Point B and point F satisfy that inequality, right? The system of inequalities. All right, let's look down at the go, right? Number 13, graph each inequality. So y is less than or equal to 3x minus 4. So it looks like they gave us space for the graph up here. Yep, so we're graphing y is less than or equal to 3x minus 4. So let's get this graphed real quick. First thing we're going to do is we have less than or equal to, which means we're graphing a solid line. That's great news because it's much easier, at least on this board, to graph solid lines than it is to do dashed lines. I think I'm going to sneeze again, so thank you. If you just say God bless you in the video, thank you very much. It's very polite, so appreciate it. Where were we? All right, graphing 3x minus 4. Perfect. So first thing we're going to do is find that our intercept is at -4. We're going to put a point right there, right on the -4, right? 0, -4. That's going to be one of our points. Then our slope is 3, so we're going to go up 3 and over 1, 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 and I'm missing by a little bit. There we go, that one was on. And then we can also proceed sort of down to the left a little bit. And now we will draw our line, right? This is the one where we can really draw like a pretty straight line here because it's solid. So there we go, that's our line. And now we need y, right? Our y values, we can only take, so if we're looking at y values that's up, down, we can only take points that are down from this line, right? Less than or equal to the line. So only points that are below that line, which means we're looking at points in this shaded region. Right, there we go. Right, so this is our shaded region here. And that should be good. There we go. So that is our shaded region for number 13. Let's move on and see. Let's see about number 14. So we're going to make this, we're also going to make this one green and up to 3. Just so we can expedite the process a little bit. So we're skipping 14 and 15. I believe we're doing 16 at the top of the next page. Yep, we are indeed. Here's 16. All right, so 16, we have 3x plus 4y is less than 12. All right, so less than 12 means we're going to be doing a dashed line, right? And let's figure out our intersects. 3x plus 4y is less than 12. So that means if we have 0 for x, right? If x is 0, then y must be 3, right? If x is 0, y needs to be 3. And if y is 0, x needs to be 4. So those are our 2 points, right? If we can see them, right? We have one at 0, 3, and another at 4, 0, right? So those are our 2 points. And then we need to make a dashed line connecting those. So we will go, right, dashed line connecting. Right, it's not going to be perfect, right, but it's going to be pretty good. And now the question is, do we need to be above or below that line? Well, we know that x and y, right, some combination of x's and y's need to be less than 12. Well, if x and y were both 0, right, let's consider this point here, right? If x and y are both 0, right at the origin there, would 3 x's and 4 y's, right, would 3 times 0 plus 4 times 0, would that be less than 12? Yes, absolutely, right? We have 3 times 0 is 0, plus 4 times 0 is 0, right? If we plug in this point at the origin, we're going to have 0 is less than 12. That is correct, right? 0 is less than 12, which means we can shade the entire portion underneath, right? Underneath this line. Right? There we go. So that is our shaded region there. Perfect. So that's 16 done. Let's move on. It looks like we're skipping 17, but we are going to complete question 18. 5x plus 3y is less than or equal to 15. So let's move over because our graph for this situation is here. 5x plus 3y is less than or equal to 15. So we have less than or equal to 15, which means we are doing a solid line. So if 5x equals 15, that means that y is 0. So if y is 0, we get 5x equals 15, which means that x has to be 3. That's going to happen right here. And if our x is 0 and we have 3y equals 15, that means we're going to be able to put our y-intercept right there. Now we're going to draw a straight line connecting the two of them. It's going to be, oh, I don't love how that one went, so let's try it again. One more time. Here we go. Oh, that one's even worse. No good. No good. One more time. One more time. This freehanding stuff is pretty hard. You know what? That's fine. That's good enough. It's not perfect still, but it'll work. And we have these two things have to add to be less than or equal to 15. Well, we once again can check, right, our point right here. If we plug in 0 for both, we'd have 5 times 0, which is 0, plus 3 times 0, which is 0, and that is less than or equal to 15, which means that we are going to do the region that does contain the origin, right? So we are going to do this region here, right? All of this space, there we go. All right, and that is the end of 18, which in turn is the end, I believe, right? We scroll down. Yep, that's the end of Unit 5, Lesson 7. So, good work getting this far. I hope it was helpful.